So dealing with multiplication um, in lots of different contexts really requires us to lean on both the commutativity and the associativity of multiplication, the associative property of multiplication. So here's a classic example. We know 3 times 5 is 15. So what's 300 times 5? Oh no, 3-digit multiplication. Okay, over here, 5 times 0 is 0, 5 times 0 is 0. Now I can actually do 5 times 3, 15. You don't have to do it that way. 300 times 5 is really easy, right? I hope you all did that in your head. 300 times 5 is 1500. Why don't we need this? Because multiplication is associative. So writing out these steps might seem like I'm making the problem a long problem, but I'm really just showing what we're doing in our head, right? 300 means 300. Well, instead of associating the 3 with the 100, I'm going to associate the 3 with the 5. 3 times 5, that's 15. Then 15 times 100 is 15 in the hundreds place. Right? Ones, tens, hundreds. I've put 15 in the hundreds place. Now, whether I say 1500 or 1500, hopefully we know those mean the same thing. Right? I'm ignoring the zeros because of the associative property. I can do 3 times 5, then times 100, and I'm all good. So what does this have to do with sign numbers? Well, we really do the same thing when we do -3 times 5. -3 is the opposite of 3. So here's my number line. How do I turn 3 into a -3? Well, I put a dash in front of it, but what operation do I use? I use multiplication. I'm saying -1 times 3 times 5. We've talked about how 0 is the additive identity. Well, 1 is the multiplicative identity. Anything times 1 is that thing. Right? 1, when we multiply, has no effect. So 3 times 1 is still 3, but to make it negative, I can put that negative with the identity. Now I am changing. The opposite of 3 is not 3. The opposite of 3 is -3. -1 times 3 is -3. So -1 times 3 times 5. I'm mixing up my 2 times symbols, but they both mean times. Well, I can associate 3 with the 5. 3 times 5 is 15. So I have the opposite of 15, -15. It's the exact same when I look at -3 times -5. I don't know why that got fat all of a sudden. Right? -3, -1 times 3 times -5, -1 times 5. Well, let me associate these two, right? It's all multiplication. -1 times -1 times 3 times 5. 3 times 5 is 15. 15 times -1 is -15. Multiplied by another -1, that gets us the opposite of that. So here's 15 on my number line. The opposite of that is -15. The opposite of -15 just comes back to +15. That's what we talk about. If you've memorized 2 negatives make a positive, this is what we mean. When we reverse a reverse, we're right back on the positive side where we started. So if I have -3 times -5, the shortcut here is just to cancel out those two negatives. I've jumped to negative, jumped back again to positive, and it's the same as +3 times 5, +15. This works if I have a whole bunch of numbers being multiplied. -3 times 7 times 2 times -6 times 5 times -1. Well, all this stuff to multiply. 3 times 2 is 7. 3 times 7 is 21. 21 times 2 is 42. 42 times 6, I don't even know. Let's see, 2 times 6 is 12. 4 times 6 is 24. So 252. 252 times 5. That's too much to do in my head. But even then, did you hear me say -6 or -3? No. We're dealing with multiplication, and then we're dealing with these signs. This really means -1 times another -1 times another -1. And here you see why we use parentheses, right? So we can make very clear what's being multiplied. Times, I don't want to do 3 times 7 times 2 times 6. That's too much. 2 times 5, that's 10. That's really easy. 3 times 7 times 6, well, 7 times 6 are pretty big, but I still have that memorized. 7 times 6 is 42. So there's 10 times 42. So I've done 2 and 5, I've done 7 and 6, then times 3. So 42 times 3, but I can do it in my head. 2 times 3 is 6, 4 times 3 is, I'm not writing this quite right here. There we go. 42 times 3, 2 times 3 is 6, 4 times 3 is 12. I'm not multiplying by 126. I multiply to get 126. I can do that off to the side if we need to. 3 times 2 is 6. 3 times 4 is 12. Then 126 times 10. I just put the 0 there, right? The 126 is now in the tens place. I certainly don't want anyone to waste time doing this nonsense. 1 times 6 is 6. Right? If nothing else, wait, is this a 6 or a 0? Right? Especially when we're rushing, our handwriting can get in the way. This is actually making the problem harder for you, not easier. So when we're multiplying by 10 or 100 or 1,000, just put those zeros at the end. Right? When we're dividing by 10 or 100 or 1,000, just knock those zeros off to move our places further back in place value. And then if we get into decimals, we'll deal with that. So 2 times 5 times 7 times 6 times 3 is 1,260. But I had these two negatives here. Those two negatives together give me a positive. We'll change color here to make it easier to see. Those two negatives, the reverse of 1,260, the reverse of that, the opposite of a negative is positive. Then I've got a third negative here, negative. So the answer to this is negative 1,260. When you're multiplying negative numbers, don't try to keep track of the sign of your term all the way along. Right? This is all one big term. I'm not adding anything else to it. It's a single big term. Don't keep track, okay, negative 21 times positive 2, that's negative 42. Negative 42 times negative 6, okay, that's going to be positive. It's really hard for your brain to keep track of the sign and keep track of the product as you go along, both at the same time. Do your product of the whole numbers, of the positive numbers, then go back and look at the signs. Or look at the signs first. These two negatives cancel to positive. A third negative makes it negative. Write your negative there, and then do the whole number arithmetic. Either looking for shortcuts like 5 times 2 is 10, that makes everything easier, or you can go left to right if that's your choice, and you get the same answer if your pen doesn't do weird things here. Right? And that comma is optional on your homework. It won't dock you if you skip the comma. Right?